right? This is a general slide, everyone knows well, but still I want to highlight one important point. Here, efficiency point. Next, bidirectional. These two are very important to improve the reliability of the system. If efficiency is good, right, you can operate the drive more period. Now, see, if you take IC engine, efficiency of the IC engine in general it is less than 45%. If you adopt PMSL machine, you will get more than 95% efficiency, right? If efficiency is closely to 100, what is the advantage? Anyone? If efficiency is good, what is the advantage? See, efficiency is 45, less than 45. Remaining energy, where it will go? It will go in terms of heat, no option. Remaining will convert it in terms of heat only. Heat energy is more, reliability will come down. You cannot operate the drive continuously. That is the issue with efficiency, lower efficiency. Next, one more important thing is bidirectional option. You won't get in IC engine, but bidirectional power flow option is, you will get option once you adopt electric machine in EV application. During a deaccelerating condition or braking mode, your drive will enter in generating mode. During generating mode, you can charge whatever auxiliary batteries are there, you can charge the auxiliary battery. This is one of the advantages. Next, one more important parameter is power density. See, there is if you take aerospace application or submarine application, even if you take EV application, there is a limited space is available for drive. Less space, but requirement is more power. In that case, you have to select proper motor, proper drive. Right? By selecting proper drive, we can satisfy the customer, at the same time we can satisfy the space constraint also. In that case, power density, IC engine power density is very poor. But if you take electric machine in EV application, it will occupy less space, it will produce more than 150 kilowatt power. That is the advantage of electric machine if you adopt in transportation application. Now this is complete overview of the electric propulsion system. Right? There are so many topics are there, areas are there. So our main focus is on these two topics: electric motor and electronic controller. Why these two are very important areas in electric drive? See, what type of motor you need to select, it will decide based on the torque profile of the machine. Nothing but, see, there are different types of machines. They are using DC machines, induction motor before 1970s. So what is my request is, try to remember this year. Later at the end of today's session, you will get more clarity about what is the significance of 1970s. Before 1970s, most of the EV vehicles were operated with the DC drives. After 1970s, see, applications of the AC drives increases gradually in EV application. What is the reason? I will explain through mathematics. Then only you will get clarity. Right? So, first we need to understand what are the types of electric motors are available. See how to decide the controllability of the motor, how to decide the reliability of the motor. First we will try to focus. After that, we will try to focus on software side. What is software? See, electronic controller side, it requires two things. One is software, another one is hardware. Hardware nothing but whatever controller, DSP, microprocessor, or FPGA boards, whatever controller you are using, physical module, to execute your software. What the name is there technically? What is software? What it means software? Don't think software nothing but MATLAB or some code composer studio. Software is nothing but idea. Implementing idea. See, the beauty of electronic controller is whatever idea is there in your mind, that idea first you have to convert it into mathematics. Through mathematics, right, we can execute our idea through the controller. So see, once you execute your idea through this processor, then expected output of the controller is you will get pulses. No option. Whether you are using scalar method, old method, conventional methods, or advanced methods, the expected output of the controller is finally it will produce control pulse. By changing the on and off period of the pulse, we can regulate the voltage as well as frequency of the motor terminal. By controlling the voltage and frequency of the motor terminal, we can control the torque generated by the motor. By controlling the torque generated by the machine, we can control the speed of the shaft. That is what we are doing. This is simple process behind the EV vehicle. First important thing is, what is the need of the customer? What is the customer required speed? They will get. Then based on the required speed, suppose in three-wheelers or e-bicycle, their requirement is they doesn't expect high dynamic performance, right? Even drive is accelerated slowly, also they are not bothering. But in four-wheeler application, their requirement is acceleration should be high. Based on need of the customer, you need to select proper idea, method. You need to select, see, based on the method, immediately you have to decide you have to calculate what is the execution time. This is very important, right? Once you know the execution time, it is not a big deal to decide the sample time of the controller. So whatever sample time you are selecting, within the sample time you have to execute the logic, right? After that, within the sample time you have to decide what voltage we need to apply in the next sample. You have to decide within sample time. But your idea is good, but see, while writing the program, length is more, it will take more time. Execution time is more, you don't have any option, automatically have to increase your sample time. This is the issue with execution time, right? So later, at the end of this session, I will explain what is the relation between the execution time and sample time, how to minimize. Later I will explain, right? So finally, here under software side, there are so many methods they have proposed in the literature, scalar control methods and advanced control methods. In general, scalar control methods, they are using for low performance drives, less than 5 kilowatt power drives. They are using scalar control method. But more than 10 kilowatt power capacity application, they are using vector control method. What is the basic difference between scalar and vector? I will try to explain through math. So these are the applications of the EV motors. See, if you observe these models, before 1970s, most of the EVs were operated with DC drives. Later, if you observe, most of the drives are operated with AC. So to understand this one, you need to concentrate only two parameters. So in today's session, our aim is understanding what is the relation between the controllability. Why these two parameters are so important to select the drive. Before selecting the drive, you need to verify these two. Later, efficiency, power density, everything we'll try to discuss. First, controllability and reliability. These two are very important parameters to decide or to select the drive in any application, EV application or aerospace or submarine application. Now come to controllability point. So this is called evaluation sheet, grade sheet, right? So DC drive is there, remaining all are these four are AC drives. This is the comparison sheet, grade sheet, right, between DC drives and AC drives. Now come to controllability. With respect to controllability point, DC drive got 5 out of 5. Maximum marks is 5. What is a good thing? It is ideal machine. With respect to controllability, it got 5 out of 5. But AC machines, if you observe induction motor or PMSM machines, synchronous electric motor, see here, you cannot get 5 out of 5. Controllability is very poor. But with respect to reliability point, if you observe reliability point, DC motor got 3 out of 5, very less. But AC drives, if you observe the AC drives, reliability is very good. Now my question is, what is reliability? What is controllability? Why controllability is very good for DC? Controllability is nothing but it depends on the mental behavior of the system. Reliability is nothing but it depends on it will decide based on the physical structure of the system. One is mental characteristics, another one is physical characteristics. You got my point? These two are very important parameter to select the driving EV application. Now, see, controllability is nothing but is it related to mental or physical? Control ability. It is related to mental behavior, right? Reliability is nothing but it is related to physical characteristics. Now, through this equation, first I will try to explain what is the mental behavior of the DC motor, what is the controllability, whether controllability is simple or complicated, we can decide based on this equation. This is called universal torque expression, which is applicable for all electrical drives except switch reluctance motor. Right? Why this equation is not applicable for switch reluctance motor? Anyone? This equation is applicable for DC motor. This equation is applicable for induction motor, PMSM, BLDC, synchronous reluctance motor, except switch reluctance motor.
In switch reluctance motor, the phases are independent, right?
This is a mathematical model for reaction time. After interacting the stator flux and rotor flux, you will get this component. In general, there are two different types of torques they will produce by using different stator structure as well as rotor structure. One is reaction torque, another one is reluctance torque. Right? So in DC machine, induction motor, synchronous machine, right? Permanent magnet synchronous machine, conventional synchronous machine, BLDC motor. See, reaction torque is more dominant. If there is any salience in the rotor side, then reluctance torque will enter in the picture. There is no flux, there is no winding on the rotor side, there is no flux on the rotor side, you will not get any reaction torque. This is the mathematical model for reaction torque, electromagnetic torque. Right? Now, this equation is applicable for all electrical drives. Now, I will try to apply this equation to DC drives, AC drive also. Under AC drive, I will take, we have limited time, I will take only induction motor initially. Later, I will explain what are the challenges with respect to PMSM machine in EV application. I will try to explain. Now, take DC machine. In case of DC machine, what is the order of the torque expression? Expected output of the DC motor is torque. Based on the torque profile, we can decide controllability. Now, what is the order? How to decide the order of the system? How to